Okay, now can I
Yeah.
share my screen? Yes, hope my screen is visible.
Yeah, yeah, man.
So first topic is OSPF neighborship estates. Okay, first
Yeah.
state is there are 7 states, and first state is down state. Second state is init state. Init, or you can say attempt. On serial link, it will be attempt, and in case of static neighborship state, second state will be attempt. Otherwise, second state will be init on Ethernet link or on broadcast network. Third
Okay.
state is two-way. Fourth one is access start. Fifth one is exchange. And sixth one is loading. And last one is seventh one is full. Full means OSPF router have exchanged all database. Okay.
Okay.
So in OSPF there are two types of neighbor. There are
Two times.
two types of neighbor. फर्स्ट वन इज नेबर विदाउट एडजेसेंट. मतलब ऐसे कहते हैं ना कि भाई एक नेबर तो है मेरा, लेकिन उसके साथ मेरी ज्यादा बनती नहीं है, खाना पीना मैं एक्सचेंज नहीं करता उनके साथ, है ना. और एक नेबर कैसा
Yeah.
होता है जो एडजेसेंट होता है, जिसके साथ आपके घर में कुछ भी स्पेशल होगा तो आप खाना भी शेयर करते हैं उनके साथ. ये सर नो.
Yeah.
सो उसी तरीके से ओएसपीएफ में दो टाइप के नेबर होता है, एक नेबर विदाउट एडजेसेंट और एक नेबर विथ एडजेसेंट. सो नेबर विदाउट एडजेसेंस जो होगा उसके साथ राउटर कभी भी डेटाबेस एक्सचेंज नहीं करेगा. राउटर विल नेवर एक्सचेंज द डेटाबेस विद द नेबर विदाउट एडजेसेंट. सो फर्स्ट वन इज नेबर.
You started recording or?
यस यस यस, सॉरी. Okay, neighbor without adjacent, and another one is neighbor with adjacent. Done. So neighbor with adjacent will go in which state? In full state, and neighbor without adjacent will stuck in which state? In two-way state. Okay, clear?
Yeah.
Done. Now guys, now see big key. Down state means what? Down state means suppose I have two router R1 and R2. Both are connected through one link. Done.
Mm.
R1, R2. Okay. So here when router 1 will, you will configure OSPF on router 1. Suppose here I am running what IP 12.1.1.1. Here I am running IP 12.1.1.2. Okay. So on router number 1, if you will configure OSPF, what will be the command to enable OSPF? Router OSPF
Router OSPF
and then
area
network.
network. Okay.
Then network 12.1.1.0 wildcard mask 0.0.255 and area will be what? 0. Yes.
So area we need to add before, right? Like that, or
Area concept
router
we will
OSPF
understand later.
area. Okay. No, no, no. I am asking that router we are enable that protocol, no? That OSPF,
Yes,
and
OSPF
after that
work on the
area
basis
should
of
come. Or,
area. Like in you know, here you have to define process ID as well. Router OSPF process 1.
yes, yes,
Yes
okay.
or no? And OSPF work on the basis of area concept. So later on we will understand area. Just consider this is the command to enable OSPF on router number 1. So
Okay.
once I
Okay.
will run these two command on router 1 will do what? Router 1 will start sending hello message from here. Yes or no?
Yes.
One hello message. You already know the content of hello message. In last class we had discussed that.
Yeah. Hello message only we saw. That rest of things we didn't saw.
Yes.
That
So
is pending
inside the
actually.
hello message there will be lots of information like router ID of advertising router, right? There will be
Yeah.
information
Router
of
that.
version, network type, subnet mask,
Version,
hello time, hold on time, authentication type, authentication data, right?
yeah. Yes.
These things will be there inside the hello message. So hello message carry this information. But until and unless you will not configure OSPF on router 2, router 1 will not receive any hello message. Yes or no?
Yeah. Correct.
Router 1 will not receive any hello message. Router 1 is only sending hello message. So the interface which is only sending hello message and not receiving hello message, the state of that interface will consider as down.
Done.
So down means router is not receiving any hello message. Okay.
Okay.
So here till now my state of this interface is down. F0 slash
Down.
0 is down. Suppose this is 0 slash 1. Once I will configure OSPF on router 2. Router 2 on router 2 also you will run command router OSPF process ID
Router.
1 and network 12.1.1.0, 0.0.255 and area 0. So once you will run these two command on router number 2, router 2 will also send what? Hello message. Yes or no?
Yeah.
Now router 1 is sending hello message as well and receiving hello message as well. Yes or no?
Correct. Once we assign that IP address and routing, these two things, after only the hello message will start. Correct.
Yeah, exactly.
Okay.
So when router is not receiving hello message, the state is what? Down. Once router
Down.
will
Yeah.
receive a hello message, state will move from down to init
Down to unit.
or
Okay.
down to attempt in case of serial link. But here between router 1 and router 2, I am using Ethernet link. So state will be init. Okay.
Okay.
After that,
Init means
init means
initiate.
router
Correct.
is, yes. Router have received hello
Initiate.
message on that interface.
Hello.
Yes
Okay.
or no? Okay,
Yeah. Okay.
inside the hello message, we had discussed that there will be information of neighbor router ID as well. But inside the first hello message, router will put their on router ID only. Suppose router ID of router 1 is 1.1.1.1. Router ID of router 2 is 2.2.2.2. Done. So
Okay.
router 1 in the hello message of router 1, there will be information about router ID of router 1. In the hello message of router 2, there will be information about router ID of router 2. And in next hello message, what router will do, R1 will send their on router ID as well. Their on router ID as well as neighbor router ID. It will say that my router ID is 1.1.1 and my neighbor router ID is 2.2.2.2 because router have received one hello message from router 2. Now router 1 have knowledge that my neighbor is 2.2.2. Yes or no?
Yeah.
In the same way, when router 2 will send hello message to router 1, inside that hello message also router 2 will put both router ID, their own router ID as well as router ID of their neighbor. So my router ID is
Neighbor.
2.2.2.2 and my neighbor router ID is 1.1.1.1.
1.1.
Yes or no? And once router will receive a hello message with their own router ID, state will move from init to two-way.
Need to. Okay. To.
Okay. Let me show you practically. See here, between
Yes.
router 1 and router 2, I am going to configure what? OSPF. Or let me connect one more router over here. I am connecting one more router over here with Ethernet cable. Okay, Vicky? Vijay?
No. Vijay.
Sorry.
Okay, maybe evening batch, that guy named Seki.
Okay. So on router number 2, let me configure one IP address on interface f1/0 say no set, and IP address, let's say 14.1.1.1 255.255.255.0. Okay. On router number 4 also I need to configure one IP, and then I will configure what? OSPF. Before configuring OSPF, what we will do? We will capture the link. In last class, we had discussed the content of hello message. We had seen practically as well. So there was
Yeah.
information about their own router ID as well as router ID of their neighbor. 4.4.255.255.255.0. Done. Now I am going to capture this link.
You already assigned rest of R1, R2,
Yes, yes,
R3.
yes,
You
yes, yes,
already
yes.
assigned.
Later on,
Yeah.
we will use this topology. I will remove this one.
Okay.
Just I am, showing you the router, neighbor router ID will be there inside the hello message. But not in the
Okay.
first hello message, because until and unless router don't have knowledge about their neighbor, how they can provide neighbor router ID, yes or no? So in
Correct.
first hello message, both router will send their own router ID
Informations.
only.
Okay.
And in second hello message, it will put their neighbor router ID as well, and once a router will receive the hello message with their own router ID, state will move in two-way state from init.
2 ways. Okay.
Otherwise neighborship will stuck in init.
You need. Oh, understand.
Getting my point?
Yes.
Great. So now on router number 1, I am going to configure OSPF, because here you can see the capturing. Let me take you on router 1.
Yeah, 1 minute.
Okay, okay. So see, router 1 is sending this hello message. Inside this hello message, there will be information of router ID of router 1 only. You can see source OSPF router ID 14.1.1.1. Yes or no, Bijay?
Yes.
Is there any information of neighbor router ID? No. Because until and unless router will not receive hello message from their neighbor router, router 1 will not put the router ID of neighbor router. So actually now router 1 is only sending hello message to router 4, and router 1 is not receiving any hello message. So a state of this interface is now down. Now let me configure OSPF on router number 4 also. Router OSPF 1 network 14.1.1.0 0.0.255 and area 0. Now see the hello message. Okay. In this hello message,
Yeah.
who is sending this hello message? 14.1.1.1.
14.1.
Okay.
Yeah.
After receiving hello message from router number 4, router 1 is sending this hello message. And now here you can see active neighbor router ID is what?
14.1.1.4.
Yes or no? So let me
Yeah.
configure router ID as well on router. So do clear IP OSPF process. Say yes. And router ID. Let's say 4.4.4.4.
So you are adding that IP address or
I
ID?
am adding router ID.
What?
Manually you
Router
can
ID.
configure
Okay.
router ID, na? Okay. Now I have configured router ID 1.1.1 on router 1, 4.4.4 on router number 4. So in the hello message, if you will check in any hello message, let me open this hello message. 14.1 is sending this hello message, on which multicast address 224.0.0.5, which is listened by all OSPF router. And here see the active router ID, active neighbor router ID is 4.4.24 and source OSPF router ID is 1.1.1. So both router is sending their neighbor router ID as well inside the hello message. Yes or no?
Yes, sir.
Just be 1 minute. Okay. So on router will see their on router ID in the field of active neighbor in hello message. State will move from init to two-way. Okay. After that, in two-way state there will be some election of DR and BDR. Election will happen in which state? In two-way state. In two-way state, one router will become what? DR, and one router will become what? BDR. Because the link between router I am using is Ethernet, and on Ethernet link OSPF network type is broadcast, and on broadcast network type always OSPF elect DR and BDR.
So what is DR and BDR? Before we can explain that, what is DR, BDR?
Okay,
and,
okay,
what is
okay.
the-
See here, suppose I have, let me design one topology over here. I have router 1, I have router 2, I have router 3, and I have router 4 over here. Okay, suppose these all router are directly connected with one switch. Clear? Suppose router ID of this router is 2.2.2.2, router ID of this router is 1.1.1.1, router ID of this router is 4.4.4.4, and router ID of this router is 3.3.3.3. So tell me how many OSPF adjacency will be there on router number 1? 3. Router 1 will form full adjacency with router 2, router 4 and router 3. Yes or no? In the same way, router 2 will also form full adjacency with router 1, router 4 and router 3. Yes or no?
Yeah.
In the same way, all router will form full adjacency with all router. So tell me, total number of adjacency in this topology will be 12. Yes or no? 3 neighbor will be there, 3 neighbor will be there, 3 neighbor will be there, and 3 neighbor will be there. Yes or no?
Okay.
So total
Yes.
number of adjacency will be what? 12.
Okay.
So whenever you will add one network over here, or suppose you are adding network or your network is going down, so this router will generate update message, and that update message will be sent to all neighbor. Yes or no? So it will send to router 2 also, it will send to router 4 also, it will send to router 3 also. Yes or no?
Yes.
When router 2 will receive the update message from router 1, now it's responsibility of router 2 to share the latest update to their neighbor. So who is neighbor of router 2? Router 4, router 3.
Router 4, router 3.
In the same way, router 4, when router 4 will receive update message from router 1, it is responsibility of router 4 to share their neighbor. So it will send to this router also, it will send to this router also. In the same way, all router will send the same update message to all their neighbor. Yes or no?
Okay.
So this is what? This is flooding. Yes or no? Lots of messages are flooding in this network.
Correct.
Because there are more number of adjacency. Like in a classroom, suppose there are 100 students, and if someone is coming in classroom and they are asking what is the date today, and if everyone will answer right, then
Correct.
there will be crowd. Yes or no?
Yes.
So how we reduce this crowd? By selecting one people as monitor. So there is one monitor in classroom. Whenever someone will ask something in class, only monitor will reply them. Yes or no?
Correct.
When a student need to talk to principal, a student will talk to monitor, and monitor is responsible to forward their message to principal. Yes or
Fine.
no?
Correct. Yeah.
In the same way, here in this topology, flooding is occurring. So to reduce this flooding, we have concept of DR and BDR. Okay.
Okay.
Out of this 4 router, one router will become DR. Suppose this router is my DR. Router who have highest router ID will become DR. First of all, it will check priority. So by default, priority on all interfaces 1. So
Three.
priority will tie. So then
Yeah.
router will check highest router ID. Router who has highest router ID, that router will become what? DR. And all DR
Okay.
other router will form full adjacency with DR router only. Right? So now tell me how many
Mm-hmm.
number of adjacency are there? Only 3. Yes or no?
Yeah.
So whenever you will add one network over here, it will router 1 will generate update message to DR router. Yes or no? And DR router will
Mm.
send to router 2 and router 3. Yes or no? Now there is no
Correct.
flooding. So that's why we come up with DR concept to reduce the
Okay.
LSA flooding. Yes or no? Or you can say to reduce the number of adjacency. Is it clear,
Very
Vijay?
good. Okay. Yeah.
So in this state, in two-way state, router will elect DR and
And
BDR.
BDR also same like that, huh?
Same like that. Suppose in a
Same
classroom,
like that.
if monitor is
No,
absent,
that
so that's why
BDR,
we have
BDR,
a one
BDR.
backup monitor. Yes or no?
No. What is the DR and BDR different?
So
DR
in the
means you told
classroom,
me
you
that.
have selected one student as monitor. Okay. Suppose
Correct. Yeah.
one monitor is absent. So who will take responsibility of monitor? Backup monitor is required. Yes
Someone
or
backup.
no? So in
Okay.
the
That is
same way in the
BDR. Okay.
network, if DR will goes down, so there will be one backup DR. B stand for nothing but
Hmm.
backup.
Backup. Okay. 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 Got it.
So
Okay.
if DR router will goes down, BDR router will take responsibility of DR. Okay,
Yeah, man.
clear?
Clear, man. Clear.
After that, in this state, in two-way state, router will check bidirectional connectivity as well. Bidirectional connectivity will be checked in this state. Once DR and BDR election will happen, a state will move in X start from two-way. But a state of router, DR other router with DR only will move in X start state from two-way state. Suppose here I have a same topology.
Okay.
This time this is my DR router, right? This is
Mm-hmm.
suppose DR other, this is DR other, and this is also DR other. Suppose there is no BDR. Okay, guys?
Yeah.
Okay, Vicky? Sorry,
No.
Vijay.
Yes.
Sorry.
Yeah. Okay.
Actually, in
It's okay.
evening
No problem.
batch, one
Yeah, I
Vicky is
know. I
there.
know that guy. Yeah. Yeah. I know that
Okay,
guy.
okay.
I saw that
So
video.
see, all DR other router will form full adjacency with DR only. Yes or no? And between DR other and DR other, neighborship will be till two-way. Okay? So
Okay.
neighborship state between DR other and DR other will not move from two-way to X start. So that's why DR and BDR election will happen in which state? In two-way state. So two DR other router will not move from here to X start. And DR other to DR neighborship will move from two-way to X start. Okay?
Yeah.
And in X start state, router will exchange what? Type 2 message. What is type 2 message? DBD. Yesterday we had discussed this thing.
Yeah. DPD.
Yes or no? Type 1 message is hello message. Type 2 message is DBD message.
DPD. Yes.
Yes or no?
Yes. Yes. Ma'am.
Okay. So now, suppose router 1 is DR, router 2 is BDR. So both will move in which state? In X start state. And in X start state, router will exchange DBD. DBD stand for database description. Okay. This router also and this router also. And through this DVD, actually this is null DVD. Through this null DVD, router will perform master and slab election.
Yeah, 1 minute. Just a moment.
Okay, okay, okay. If you want to see the DVD message, here in the capturing also you can see. Where is DVD? Here you can see DVD. Database description. Who is sending? Router 4 to router 1. First router 4 is sending to router 1. Then router 4 is sending to router 1. But in real time you will see only one DVD, not two DVD. Both router is sending how many DVD? Multiple DVD.
Okay.
DVD. Inside the DVD, if you will check, see, is there any information about prefixes? No. So this is null DVD. There is information about source router ID and area ID only. Here also you can see there is no any information about network.
Network. Okay.
Okay. So interviewer can ask you, type 2 message will be exchanged in which state? So type 2 message is DBD message and DBD message will be exchanged in X start state. Okay. So always keep in mind type 2 message, DBD message will be exchanged by the router in which state? In X.
Initiate and
In X start state.
X started. Okay.
After DBD exchange, neighborship state will move in exchange state.
Exchange state. Okay.
Exchange state from X
This
start.
is this is flow, no? This is one by one. It's a flow.
Yes, this is one by one flow.
State, huh?
Yes. Then neighborship state will move in exchange. And in exchange state, router will exchange what? Again DBD, but this time not null DBD.
Okay.
This time router will send LSA header. In exchange, router will send what? LSA header. So type 2 message will be sent in two state, in X start also and in exchange state also. Here there will be information about what? LSA header. This router also and this router also. Okay. Inside the LSA header, suppose router 1 have 3 network X, Y and let's say Z, and router 2 have some network, let's say A, B and C. Done. So in the LSA header there will be header of this network. Router 1 is sending that I have X network, I have Y network and I have Z network. In the same way router 2 is saying I have A network, I have B network and I have C network in exchange state. Once LSA header will exchange, neighborship will move in loading state from exchange to loading. And in loading state, router will send what? Type 3 message. Can you tell me the type 3 message? LSR.
Type 3 LSR. Okay.
Link state request. So see, router 1 have received header of A, B and C. Suppose router 1 does not have these prefixes. So router 1 will send the request for the detailed information of these prefixes. Okay. With the help of which message? With the help of LSR. Link state request. Okay. In the same way, router 2 will also send.
Little bit confusion, man. These things.
You need to watch this video again. Okay, everything will clear to you.
Sure.
There is nothing.
Sure.
Or what you can do, you can read these things in book.
Books,
Everything
yeah,
will be
okay.
clear to you.
Okay.
LSR,
Okay.
link state request, means router is requesting for, suppose you are in a restaurant,
Mm-hmm.
okay, and you need some food, okay.
Correct.
So first
Yeah.
of all, waiter will give you what? Menu card. Inside the menu card, there will be name of food only. Yes or no? This is not
Mm.
actual food. This is what? This is DBD. Description
Okay.
of the food which this restaurant is providing to you. Yes or no?
Okay.
So
Okay.
in the menu card, you will check the name of all food. Then you will select that, okay, I need burger. So you will send one
Mm-hmm.
request to waiter, give me
Later.
the
Yeah.
burger.
Yeah.
Yes or no? So this is
Correct.
nothing but LSR, link state
Mm.
request. I am sending one request for, out of these food I need only burger. Yes or no?
Okay.
So in the
Okay.
same way, router have sent the header of all LSAs, all network. So router is sending request, maybe for all network or some network. Yes or no? And
Mm-hmm.
then waiter will give you actual food, that is burger. Yes or no? So in the same
Okay.
way, whenever router will receive LSR, router will send what? LSU, link
Yeah.
state update. So in loading state only, link state request, link state update, and link state acknowledgement will exchange. And on
Okay.
all database will be exchanged, neighborship will move in which state? In full state. So full state
Okay.
means all OSPF database has been exchanged. Done.
Okay.
So these are neighborship state. Dawn means, again I am
Okay.
just giving you one more time overview. Dawn means
See.
router is sending hello message, but router is not receiving hello message. In it means router have received hello message and router is sending as well. But router have not seen their own router ID inside the hello message. And on router will see their own router ID in the hello message, state will move in two-way state. Here DR and BDR election will happen, then state will move in X start state. In X start state, router will exchange DBD, database description. Here master slab election will happen and MTU will negotiate. So if
Okay.
suppose MTU over here is 100, MTU over here is 200. So MTU is mismatch. Yes or no? So
Okay.
if MTU
Yeah.
will mismatch, neighborship will stuck in which state? In X start state.
Yes.
Okay.
Okay.
So if MTU is match and DVD has exchanged, then neighborship will move in exchange state. In exchange state, router will exchange what? LSA header with the help of DVD message. Okay. And in loading state, router will send LSR, LSU, and LSAC. Okay. And once database will exchange, neighborship state will move in full state. Done.
Sure.
So now on router number 1, I am able to see the state is what? Full. See here. So IP OSPF neighbor. State is what? Full. That means database has been exchanged. So if you will check database, so IP OSPF database, you can say in the database of router 1 there is LSA of router 1 also and router 4 also. Yes or no?
Yes. Yeah, it's the link ID.
If I will change the MTU over here, interface F1/0. Where is my topology? Here. Okay, F1/0. If I will change the MTU, what will happen? Let's say IP MTU 1000. By default, it is 1500 byte. So I have set it 1000. Now nothing will happen because the state is in full. But if you will clear the OSPF process, again router will form neighborship, and this time in access start state neighbor will stuck. Neighborship will stuck.
Okay.
Yes or no? So let me do that. Clear IP OSPF process. Say yes. And so IP OSPF neighbor. This time neighborship will stuck here. It will not move from access start to exchange because MTU is mismatch. Yes or no? And now if you will check database, so IP OSPF database. So see in the database there is LSA of router 1 only. Yes or no? Means database has not exchange between router 1 and
Not
router
a-
4. Done?
Yeah.
This is neighborship state. Now next topic is LSA.
Okay, man. Yeah, I will check today. This topic is enough, man. That the next topic we will see tomorrow.
Really? We have lots
Yeah,
of
I
time.
will. Okay, then. Okay, I can continue now. Yeah.
Okay, if you don't want, no problem, because this is one-to-one training. I will teach you accordingly, you only.
Now, what happened? I need to go through this because in practically, can you show me these things? Is it possible now?
Yeah, yeah,
That
practically also
how
I
it's.
have show you now. Here you can see
Yeah.
neighborship state is stuck in X start. So IP OSPF neighbor, because MTU mismatch. I told you then in X start state router will negotiate MTU. If MTU will mismatch, that means neighborship will stuck in X start state. If I will again
Correct.
change the MTU over here, interface F1/0 IP MTU and 1000, and let's say no. So again router will send what? DBD with same MTU. So IP OSPF neighbor. So now you can see the neighborship is in full state. So IP OSPF database. You can see the database. Database has been exchanged between router 1 and router 4. There is nothing, Vijay. Just you need to watch
Hmm.
this video one more time, okay? Now I am
Okay.
going to
Okay. Yeah.
disable
Sure.
OSPF over here. Say no router OSPF 1. And on router number 4, let me delete the router 4 now. I don't need it. Just I am giving you overview of LSA, okay? Don't worry, tomorrow we will
Okay.
start LSA, okay? So
Sure.
actually we have some types of LSAs. Types of LSAs. LSA stands for link state advertisement, okay? Now first LSA is type 1 LSA, and this is nothing but router LSA. Name of type 1 LSA is router LSA. Type 2 LSA. Type 2 LSA is network LSA. Name of type 2 LSA is network LSA. Done. Type 3 LSA is summary LSA. So we have to understand each LSA one by one. This is very
Okay.
important. I must tell you. Interviewer will ask you lots of questions from here. Type
These types of LSA.
yes. And if you will understand LSAs, then you can easily troubleshoot OSPF network also.
Ah. Okay.
Okay, so this is very important for troubleshooting.
Okay, man. Yeah. How many types are there? So we can complete today, or how we can do?
No, just I am giving you overview. See, type 4 LSA is ASBR summary LSA. BR summary LSA. Okay. Type 5 LSA is external LSA.
External. Yeah.
Just keep the name in mind. We will
Yeah.
understand each LSA one by one.
Sure,
Type
man. Sure, man.
6.
Total 11 types are there. Huh?
Yes, total 11 types are there. M
Oh, okay.
OSPF LSA.
Type 6. No?
Type 7 is NSSA LSA
NSSA. NSSA.
and SSA.
NSSA.
Note, so STB area external LSA. Okay. Then we have type 8, type 9,
Type
type
8
10,
and
type
type
11, but those are
7.
not in
Yeah.
use. So as a
Okay.
network engineer, till CCNA to CCI, you need to learn these LSA only. These 7
Okay.
types of LSA. Okay. And
Sure.
router
Okay.
LSA is the LSA that all router in OSPF domain will generate, right? All router in
Mm-hmm.
OSPF domain will generate what? LSA 1, that is router LSA. And there will be two information inside the all LSA. What I am saying, there is two information that all LSA will carry. Let me tell you that information. First one will be advertising router ID. Advertising router ID. All LSA will carry this information. What will be the advertising router ID? Router ID of a router who is advertising the LSA. Yes or no?
Okay.
And second information will be link ID. Link ID. So these two information will be carried by all type of LSA in OSPF. Okay.
Okay.
Advertising router ID is router ID of a router who will advertise the LSA, and link ID will be in some time link ID will be router ID, and in some time link ID will be prefix information, or you can say link information. Link information. OSPF does not share their routing table. OSPF exchange what? Link state information. And by running SPF algorithm, router itself calculate what? Routing
Calculate
table.
that routing table. Okay.
So tell me, when you want to start LSS, tomorrow or today?
Yeah, better we can go for tomorrow, man.
Okay, no problem then.
Yeah, this I need to go through it.
Okay, no problem. Tomorrow we will start LSA.
Yeah, okay, man. Okay.